Assalamu alaikum. On behalf of Ahsan Academy, let me welcome you to a presentation on oogenesis. In this presentation, I will try to define oogenesis, explain or describe the background idea of the site of oogenesis, steps of those oogenesis along with the events occurring in each steps. Oogenesis describes the process of conversion of germ cells into female gametes. This is actually the process that includes all the events by which oogonia, that is the germ cell, is differentiated into a mature oocyte. So germ cells forms the female gamete, that is includes that actually happens through a series of events. So these events together is known as a process, and by this the oogonium is converted into a oocyte. You can see this is the oogonium, and oogonium is a type of germ cell, and the oocyte is the mature female gamete. This happens in the internal reproductive organ of the female, that is the ovary. You can see the ovary and different stages of follicles are shown here. This is the starting point, and gradually this is changing, and this oocyte is expelled out, and the remaining supporting portion gradually disappears. So reproductive process actually starts with the maturation of oogonia to a oocyte. So this is known as oogenesis, and this is the beginning, and the process ends by delivery of a mature baby. So in between there are several stages, means oogenesis expels the after formation of the oocyte. This is expelled out of the ovary by ovulation, and that meets with the male counterpart to form a complete cell. This is fertilization, and then gradually the fertilized zygote increase and differentiates into, actually by cell proliferation and differentiation, it makes a complete baby, and that baby is delivered. In this way the total process, reproductive process, is completed. For the reproductive process in the female, there are several organs, and that may be external and internal. The internal organ includes, this is the vagina, that is the lower part, and then the internal, within the true pelvis lies the uterus. This is the uterine tube, and this is the ovary. So this together comprising the internal reproductive organ of the female. You can see this is the ovary that produces oocytes, and that oocytes gets inside the uterine tube to be fertilized, and these fertilized zygotes gradually proliferates, the cell proliferates and differentiates and enter into the wall of the uterus. Within that it grows up and finally forms a mature baby. During the description of the embryological development, we'll use some terminologies that I want to explain first. You see, this human body, we used to use the four terminologies: anterior, superior, posterior, and inferior. For the developing baby, we use some different terminologies. Anterior we used to say ventral, superior is to say cranial, posterior is to say dorsal, and inferior is the caudal. We use some planes to show the different layers and differentiation and formation of the organs, and we use the same planes, like this is the median plane, and all parallel to those are the sagittal planes. So the same thing will be used in case of the embryo. and the medial and lateral terminologies are the same. So this is the median section of the developing embryo. You can see this is the embryo and these are the supporting membranes. So embryo is longitudinally sections. This is the median section. You see, this is the transverse section. We use these terminologies. Here also we show this is the transverse section of the developing embryo. You see, this is the coronal section. So same thing will be used in case of the embryo developing baby, and this is the neck region coronal section. For the oogenesis, before birth, a major part is completed. So we will describe the part before birth stage by stage. So it begins in the intrauterine life, and you can see this is the developing embryo with the yolk sac, this one, and allantois, this one. This is the umbilicus through which this yolk sac is connected with the embryo, and you can see the transverse section here. So the second week of the life, the germ cells are produced in the wall of the yolk sac. You can see this is the yolk sac, and its wall there is primordial germ cells appear, and this is the primordial germ cells, you can see. And after 2 weeks, and the fourth week, the cell starts migrating through the umbilical region to the gut wall. This is the developing intestinal wall. This is called gut. So through the gut wall, through the mesentery, it goes to the posterior wall of the embryo. So this migration starts, and you can see this is the gut and this is the mesentery. So this is following the gut wall to the posterior wall. So yolk sac, umbilicus, then gut wall to the posterior wall, and then posterior to the developing gonad area. In case of female, this is the ovary. So in the fifth week, the germ cell appear in the gonad area. So you'll find that the germ cells are in the posterior wall, that is giving rise to ovary. The cells has appeared there. These are the oogonium now, and they proliferate by mitosis. We know the proliferation. Proliferation means increasing in the number by mitosis. So oogonia divides again and again. So let us continue with the before birth. At the end of third month, means 12-week time, the oogonia form cluster covered by flat cells. So oogonia there, these are the large cells of the oogonia, and some supporting cells are there that surrounds the oogonia and cluster of oogonia. So they continue, oogonia continue proliferation, increase in number by mitosis, and some of them, the end of the third month, enters into meiosis. So meiosis division, we know that completed in 2 stages, meiosis 1 and meiosis 2, and each stage has prophase, metaphase, anaphase, and telophase. So meiosis 1 has a very long prophase, and prophase has several stages. So it starts the first stage there. So condensation of the new chromosomal material takes place, and it proceeds to the second stage and so on. So it is in the prophase, and some of the cells enter into the prophase, early part of the prophase, and it cannot complete the prophase of the meiosis and is arrested in the stage of diplotin. So all will start prophase, but will not be able to move to the diakinesis. Before that, this will stop, and this is known as primary oocyte. So primary oocyte is the oogonium that has entered into meiosis but arrested in the prophase before diakinesis. So this is diplotin stage of the meiosis 1, and this cell is known as primary oocyte. So we will be able to see primary oocyte at the beginning of the 4th month in the developing. Still, let us discuss the before birth. So this is increasing in number, and 5th month we will find that the ovary has maximum number of germ cells, and is approximately 7 million germ cells. After the 5th month, the cell gradually starts dying. So death begins, and both oogonium as well as oocyte, some of the oocyte die. So the number declines gradually, very slowly. In 7 months, a few oogonia remains, and most of the oogonia enters into the meiotic division, arrested in the diplotin stage. So these are the primary oocytes. So a few oogonia is left, and in the 7 months we will find most of the cells, germ cells, are primary oocyte. This is one primary oocyte. This is the nucleus. The dot is nucleolus, and it is surrounded by so many flat cells. A single layer of the flat cells is surrounding it, and these flat cells are called parafollicular cells, and together this is known as primordial ovarian follicle. Follicle means flower. It is the flower of the ovary. So this is single layer of flat cells covering totally the one primary oocyte. This is called primordial ovarian follicle. These all are primordial ovarian follicles. Sometimes we may find 2 oocytes in one follicles in the before birth. Maybe it's some small clusters. You can see this is the primary oocyte surrounded by flat cells. So each are separated now. This is known as primordial ovarian follicle. The ovary is now full of primordial ovarian. So at birth, all the germ cells, there is no oogonia, all are now primary oocyte. So all are displayed as primordial ovarian follicle. So at birth we will find that ovary has cortical area and the medullary area. Outer part is the cortical area and containing many primordial ovarian follicle in the cortex. This stage continue, and the ovarian size increase because of the increase in the stroma, not the germ cells. So germ cells will never increase after birth, and usually they will decline in number because of death of some oocyte. So from the puberty, again the development starts. The puberty age is usually 11 to 13. So after birth, let us discuss what happens when the ovary attains the pubertal age. Female reproductive age ranges from puberty to menopause. Puberty means onset of the reproductive life, and menopause is the cessation of reproductive life. Usually 11 to 13 is the puberty age, and menopause is around 45 years of age. So during this period, there will be some hormonal change, the hormones secreted by the anterior pituitary and ovary cell. So the anterior pituitary hormone and this ovarian hormone together influences the endometrium of the uterus for conception of the baby. On the other hand, this anterior pituitary hormone influences the ovary to induce some change, and this is the oogenesis occurring in the rest of the afterbirth part of the in the ovary, and this is ovarian cycle of oogenesis to produce mature ovum with each cycle. And the change in the uterus, the endometrium of the uterus, is ovarian cycle is called the maturation that induces the maturation of the primary oocytes is called the oogenesis, rest of the afterbirth part of the oogenesis. So in each cycle there will be 15 to 20 follicles which we have identified as primordial ovarian follicle starts maturation. So rest of the primordial follicle remain in rest, but this targeted 15 to 20 follicles in two ovaries gradually shows the changes, and there are three stages that is explaining the changes. One is the primary or pre-antral phase, secondary or antral stage, this is the longest stage, and pre-ovulatory or Graafian follicle stage, this is the shortest stage. So these three stages, now I will explain. Primary or prenatal stage, the primary oocyte grows gradually, increases in size than the other, and develops a non-cellular membrane around it. This is known as zona pellucida. This follicle, you can see, this is the follicle, and here this is the oocyte. This is larger than other oocytes that is present within the primordial ovarian follicle. So this is under growth, and you can see that gradually this is increasing in size, and also there is division of the flat cells that remain around the oocyte. So this is now increasing in number, gradually change in shape, and become cubical in shape, single layer. Then when the single layer is covered, the second layer shift to the second layer, so 2, 3, 4 layers of cells are produced. So this becomes stratified layer of cell around the developing oocyte. This is now known as granulosa cell. You can see this is the oocyte, and these are layers of granulosa cells. So this is known as primary ovarian follicle with single layer or multi-layer. This is multiple layer of granulosa cells. So all are primary. This is with the single layer, two layers, multiple layers of granulosa cells. There is some changes in the connective tissue surrounding the follicle. So become very vascular. Here, this is the connective tissue showing some changes. This is known as theca folliculi. You can see this is the oocyte, these are the granulosa cell. Secondary or antral stage, a cavity appears. This is the cavity, we can see in between the cells of granulosa cells, and this may be multiple. So follicle is filled with space and in between the cells, and this is known as antrum, and this antrum become larger, fusing together and increasing in size. So this is called the follicle with the antrum is known as with the vesicle. You can say this is the cavity is called the secondary ovarian. Now secondary ovarian follicle continues to grow, and the antral size increases gradually to a very large size and occupy most of the part inside of the growing follicle. And this follicle may increase in size and even become 24 millimeter or 25 millimeter or more. You can see this is now very large ovarian follicle, and each a large ovarian follicle comprises of one oocyte. You can see this is the oocyte and surrounded by zona pellucida, surrounded by some cells. These are the granulosa cells. This is known as cumulus ovaricus, total known as cumulus ovaricus, and the cell surrounding is at the corona radiata cells. These surrounding cells, 2 layers, 3 layers, are known as corona radiata cells. This is antrum folliculi. This is granulosa cell, and ovarian cell converts into thecal cell, now having inner layer close to the granulosa cell and outer part, so theca interna and theca externa. So this is the figure of a mature ovarian follicle showing.
During fetal development, stem cells, called oogonia, go through mitosis. Some of these cells develop into 46 chromosome primary oocytes. At the onset of female puberty, tens of thousands of primary oocytes each form part of a primordial follicle in the ovaries. Between menarche and menopause, each primordial follicle develops into a mature follicle, and its primary oocyte completes meiosis I. Some primary oocytes become secondary oocytes, 23 chromosome cells that begin meiosis II, then pause. Each month,
This is primary ovarian follicle, and this is has converted into secondary because antrum is there, and antrum gradually increases in size, and during this period this primary oocyte shows some changes, and this first meiotic division is completed, and the first meiotic division is reduction type, so chromosome become 23 in each. This is the one oocyte takes most of the cytoplasm, and second one, this is known as polar body, remains within the zona pellucida, and this is the one which receives less cytoplasm, a minimum cytoplasm. So this is known as first polar body, and this one is continue life as oocyte. Meiosis II in either cell will be completed if this is fertilized. If not, then this will degenerate. You see, this one is 2 polar body and 2 division if this is fertilized. Otherwise, this second meiotic division will not be completed. Let us summarize the total oogenesis already we have described. So this is the first entry point. This is the primordial ovarian follicle. You can remember this is the primary oocyte surrounded by the flat cells. All primordials are present at birth. It continues this stage up to puberty. So from the puberty, with the each cyclical change during each cycle, 12 to 15 cells, the follicles are targeted. So they show the changes. So the first change, this oocyte, you can see this is growing in size, and the parafollicular cells, they're dividing and becoming cuboidal, making single layer. This is primary ovarian follicle. Primary ovarian follicle, follicular cells increase in number. So primary ovarian follicle with 2 layers, or sometimes it is known as secondary ovarian follicle, then continue to have more layers, and this become very large, and just after this stage several cavity appears within the granulosa cells. So this is sometimes known as pre-antral stage, when the oocyte is there and follicular cells surrounding it becoming multiple layers stratified in number. So now cavity has appeared. This is the antral phase, and this antrum increases in size because of the fusion of multiple, and this is now known as antral stage of follicle. So that become very large, and before ovulation, this has become a mature ovarian follicle that I have discussed previously. This is Graafian follicle, and this leads to expulsion of oocyte along with some granulosa cell. This is known as corona radiata cells, and just that time, just before ovulation, the first meiotic division is completed, and the total thing, these two cells remains within zona pellucida, but one oocyte gets all the cytoplasm and the second nucleus gets a thin film of cytoplasm and remains within the zona pellucida. This second meiotic division is only completed if it is fertilized. The remaining part of the cells that is leaving behind in the ovary converts into. Let us compare the gametogenesis of male and female. So we will discuss the gametogenesis under some headings. So relation to the birth. So before birth, in the male all remains as the stem cells, and they proliferate by mitosis and increase in number throughout the length of the prenatal life. But in case of female, we have seen that very early the primordial germ cells proliferate by mitosis, but at the middle it enters into the meiosis 1 and is arrested in that phase, and it before the half of the life this starts meiosis, and before birth all the germ cells entered into the meiosis and arrested in the diplotin stage. So the number of the germ cell become fixed at birth. So the germ cell are the spermatogonia and can proliferate at birth even after birth. But you say this ovary contains the germ cell, all are primordial ovarian follicle, and it is the primary oocyte that lies within it. All are in the meiosis 1 stage and arrested in the diplotin stage. The spermatozoa are continuously produced every day, and in case of female, each cycle 12 to 15 oocytes undergo change, and secondary oocyte discharged from one of the ovary, one from any of the ovary in each menstrual cycle. So though the 12 or 15 starting maturation, but one succeed and only one ovary shows this ovulation, and the other degenerates. So in male, the reproductive age starts from the puberty and continues throughout the life, but in female it starts at the puberty and ceases at ages around 45, and this is menopause. So the reproductive age in the female extends between puberty and menopause. Let us see the relative status of ovarian and uterine cycle. So up to puberty, there is no cyclical change in ovary as well as in uterus, and in the ovary we will find that there are ovarian follicles. These are all primordial ovarian follicles. So we can see this is the ovary, and all follicles primordial in nature and contains primary oocytes. If we look into the uterus, at birth the uterus has this body smaller than the cervix. This body is the main portion for the reproduction, and up to puberty this body increases size and become almost equal to the cervix size. There is during reproductive period, that is the reproductive age extends between puberty and the menopause. Each cycle there is 15 to 20 follicles grow to the primary stage. And during proliferative phase of the uterine cycle, the primary ovarian follicle grows to the secondary, and the follicle reaches to the full maturation gradually. Antral stage, then Graafian follicle is formed, and the uterus is still in the proliferative phase. The oocyte is surrounded by the granulosa cell. So oocyte is expelled out of the ovary. So the remaining granulosa cell forms the corpus luteum. And at the time of ovulation, the oocyte first meiotic division is completed. And this oocyte now having a polar body with it within the zona pellucida, and the uterus remain in proliferative phase. If the fertilization fails, then endometrium remains in the secondary phase for about 14 days. This 14 days is almost fixed, and so if this fertilization fails, then after 14 days the menstruation starts. So the next cycle starts. So the ovulation occurs. If we want to calculate the ovulation, we should remember this important point, that ovulation occurs 14 days before the onset of next cycle. So we can feel, the patient can feel, or lady can feel that what is the beginning of the next cycle. So from that we can gauge what. So let us try to calculate the date of ovulation in case of the female who has come to you for advice. So that person will be able to say the date of onset of the last cycle. This is first thing. And will be able to say the cycle is regular and how many days are comprising of the cycle. If the person say that the cycle is of 0 to 30 days, so you can easily imagine that comprises of 3 stages: menstrual phase, proliferative phase, and secretory phase. So from the beginning, this is the menstrual phase, and then the proliferative phase will continue, but you cannot see this. So how can we calculate it? So we know the date of the beginning. So if we add, we can imagine the 30th day and the beginning of the next cycle. So the date is known now. Now if we know that the ovulation occurs 14 days before, so this is the last date. So if we minus it, then we will find the date of ovulation. So in this way we can calculate 30 minus 14 equals 16. So from this, 16th day is the date of ovulation. Usually it is 28 day cycle, so the date will be 14. If it is 32, then date will be 18th. So this 14 days fixed and this is fluctuating. So if the duration is less than 28, this will remain fixed. So if it is 26 days, then 12th will be the ovulation date. In this way we can calculate or assume the date of ovulation, and at that time the endometrium remain in proliferative phase. Let us find the influence of these two hormones, follicle stimulating and luteinizing hormones. So these two hormones helps in completing the meiotic division and initiate the meiosis II. The rapid growth of the ovarian follicle is under the influence of these hormones, and this makes secondary follicle and then gradually antral and mature follicle even maybe 40 millimeter, means 4 centimeter size, and you see this is even bulged out of the ovarian wall and maybe even equal to the size of the ovary. and this is the ovulation. This is expulsion of the oocyte from the ovary, and this is done by the certain rise of these two hormones. This is known as pre-ovulatory surge of luteinizing hormone and follicle stimulating hormone. Thank you very much for remaining with this presentation.